So now chapter 11 in the Year 1 Pure course, which is on vectors. Again, most of this is GCSE work. So a vector is something which has both magnitude and direction. So say for example we have P and then we have another point Q. Well, the vector is what takes us from P to Q. So we'll call it PQ with an arrow above the top indicating we're going from P to Q. We might decide to call that vector I. Now these are meant to be in bold, but you can just write A, it'll be absolutely fine. What we can also know, if we're going from Q to P, so we'll go following this vector but in the opposite direction, and that would simply be minus A. We can add to it, say if we've got, that's vector I, and this is vector B, or we can simply put B onto the end of I, and then if the direct vector joining those two endpoints is C, we'd simply write that A plus B equals C. Right, let's just skip on now to the... before we do that, if, say for example, this is I, then if we have a vector that's parallel to it but twice as long, then that would simply be 2A. And you can tell if any two vectors are parallel because one will be a multiple of the other. So, two vectors are parallel if one is a multiple of the other. So if I equals scalar, we'll call it lambda B, then I, B are parallel. Okay, so that's how you prove two vectors are parallel. Okay, if we skip example 1, you can just look at example 1 itself. It's very, very straightforward. It's just a way of adding together vectors in the same way I've done here. We'll go on to example 2. So example 2, we've got a quadrilateral PQRT. We've got vectors marked on that quadrant, and you've got a point S as well. You've got vectors marked on that, and I've done those in red to make them stand out. So Q to P is A, Q to R is B, and so on. And what we need to do is work out the vectors that take us from different points to other points. So the first one being P to S. So we need to go from P to S, but there's no vector there. So what I have to do is use vectors, so only travel on lines with vectors on, or parallel to those, in order to get from P to S. So the way I'm going to do that is to go up to Q, down to S. Now because that's in the opposite direction to the vector, that's going to be minus A plus C. You can write it as C minus A, it doesn't make any difference. R to P, R to P. So look at the vectors, how you're going to get there using the red lines. Here to here, so that's minus B plus A. P to T, no vector there, so we have to go all the way around here. That's minus A plus B plus D. And finally T to S. So we're going to have to go boom, 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 minus D, minus B, plus C. Again, you can reorder into any order you like, it doesn't make any difference. Example 3, we've got A, B, C, D, where A, B, C, D is a parallelogram, and here we need to go from A to C. This is a problem because we've got no vector here. So it looks as though we can't get there, but because it's a parallelogram, we know A to D is going to be the same length and same direction as B to C. So this line here is also vector B, and this line here is also vector A. So this is now very straightforward. So A to C is simply A plus B. On to example 4, I just need to show these two vectors are parallel. All I need to do that is to show one is a multiple of another. So if we take 6A plus 8B and times it by 1.5, you'll get 9A plus 12B. Therefore, 6A plus 8B is parallel to 9A plus 12B. because the one vector is a multiple of the other. If, say, if we'd have to multiply 6 by 1.5 to get 9, but then 8 by 2 to get this one, then they would not be parallel. It's got to be the same factor for all of the corresponding vectors. Okay, example 5. We've got a triangle, ABC, where A to B is vector A to C is vector B, and we're told P is the midpoint of AB, and Q is on the line AC, such as in the ratio 3 to 2. So 3 to 2. First thing that's to do is to work out B to C. Well, B to C is just here to here. So that's minus A plus B. A to P. Well, because this is the midpoint, to go from A to P is half that of A to B. So it's just half A. To go from A to Q, a bit more difficult, but if we've got 3 units, 2 units, you've got 5 units in total. A to Q is 3/5 of the length of A to C. So it's just going to be 3/5 B. And finally, P to Q, well, we're going to go against the A, but it's going to be half the distance because this was the midpoint. It's going to be minus half A. Then we're going to get to Q. We've just done that, so that's 3/5 B. Okay, so that's all of the examples prior to exercise 11A. So I hope we got that now.